Imagine discovering another Earth, a blue planet orbiting a distant star. Scientists detect water in its atmosphere. Its temperature could support liquid oceans. Everything suggests it might be habitable. But there's one enormous problem. Even with our most powerful telescopes, we still can't simply zoom in and photograph its continents. An Earth-like planet around another star is so unimaginably distant and tiny that it may appear as little more than a point of light or be hidden in the glare of its star. But scientists have investigated an extraordinary idea that could change that. Instead of building a telescope bigger than anything humanity has ever constructed, what if we use the sun itself? Not sunlight, not solar energy. The sun's gravity. The idea is called the Solar Gravitational Lens. And if we could actually build a mission around it, humanity might someday reconstruct images of the surfaces of distant worlds. The idea begins with Albert Einstein. According to general relativity, massive objects distort the space-time around them. When light passes close to something extremely massive, its path bends. This phenomenon is called gravitational lensing. Astronomers already use gravitational lenses in space. Massive galaxies and galaxy clusters can bend and magnify the light of objects located far behind them. Sometimes the distorted light forms arcs, and under the right alignment, it can form a glowing circle called an Einstein ring. But here's the incredible part. Our sun can do this too. Imagine an Earth-like planet many light years away. Light leaves that planet and travels across interstellar space. Eventually, some of it passes extremely close to the sun. The sun's gravity bends that light far beyond the outer planets. Those rays become concentrated along a focal region. Put a telescope in exactly the right place, and the sun effectively becomes part of an enormous natural telescope. The minimum useful distance begins at roughly 550 times the distance between Earth and the sun. That's 550 astronomical units. For comparison, Neptune is only about 30 astronomical units from the sun. Voyager 1, launched in 1977, has spent decades traveling outward and is still nowhere near 550 AU. So getting there would be an enormous mission by itself. But if we could, the reward could be extraordinary. A spacecraft wouldn't simply point its camera at an alien planet and take an ordinary photograph. The light from that world would appear stretched around the sun as an Einstein ring. Hidden inside that ring would be information from the planet. Scientists would have to measure the ring extremely precisely. The spacecraft would move across the image region, collecting light measurement after light measurement. Powerful algorithms would then attempt to reconstruct those measurements into an image. Think of it like assembling an enormous cosmic puzzle. One measurement tells you almost nothing. Thousands upon thousands of measurements could gradually reveal a world. Research into the Solar Gravitational Lens suggests that this technique could potentially reconstruct multi-pixel images of nearby Earth-like exoplanets. Instead of seeing only a dot, we might distinguish large-scale surface features, continents, oceans, cloud systems, seasonal changes, perhaps even signs that something unusual is happening on the surface. And that's where this becomes far more than just photography. Scientists could also analyze different wavelengths of light that could reveal clues about an exoplanet's atmosphere and surface, water, clouds, atmospheric gases, potential chemical signatures associated with habitability, and possibly one day, clues that force us to ask the biggest question of all: is something living there? But this is where we need to separate an incredible concept from an actual mission. NASA isn't currently preparing to launch a Solar Gravitational Lens telescope to photograph aliens. The concept has been studied through NASA's Innovative Advanced Concepts program, and researchers continue investigating whether such a mission could realistically work. Because the challenges are enormous. First, we have to travel hundreds of astronomical units from the sun. That could require advanced propulsion or extremely fast solar sail spacecraft. Then the probe would need extraordinary navigation accuracy. Remember, We're trying to reconstruct a planet that may be dozens of light years away. Even tiny positioning errors could matter. Then there's the sun itself. The telescope needs the sun's gravity, but sunlight and the glowing solar corona create unwanted background light that makes measurements much harder. Scientists would need extremely effective optical systems and image processing techniques to separate the faint Einstein ring from that glare. And there's another problem. Alien planets don't sit still while we photograph them. They rotate. Clouds move. Weather changes. They orbit their stars. So while the spacecraft collects measurements, the target itself keeps changing. Researchers would need sophisticated mathematical reconstruction techniques to account for all of it. This would be one of the most difficult imaging experiments humanity has ever attempted, and yet, that's exactly what makes the idea extraordinary. For centuries, humans imagined alien worlds. Then, we began discovering them. Today, we know thousands of exoplanets exist, but most remain points, signals, shadows, spectra, and measurements, rather than detailed worlds we can actually see. The Solar Gravitational Lens represents a possible next step, not merely discovering another Earth, but beginning to map one. Imagine the day an image slowly appears on a scientist's screen. At first, just blurry patterns, then colors, a dark region, a bright region, clouds, perhaps something resembling an ocean. For the first time in human history, we wouldn't simply know another potentially Earth-like world exists. We might begin to see what it actually looks like. And the most incredible part? The telescope capable of making it possible may already exist. We've been orbiting it for our entire history. The sun,